Good morning, good afternoon, or good evening, depending on where you are. I'm Jackie Lynch, and I want to thank you for taking the time to listen to this session. This is the third part in our series on care and feeding of VIOS servers. And if you've been to the other sessions, then you know that I've been working in IBM Power and AIX for a very long time. In this session, we're going to cover LPM. We're going to look at a bit of an introduction, a lot about the prerequisites and planning, and then we'll talk about some storage-related issues. We'll go into remote migration, and we'll also look at SRR. I have a bunch of useful commands and useful links, etc., but we won't be covering those. So when we talk about LPM, that stands for Live Partition Mobility, and it is the ability to move an AIX, IBMI, or Linux partition from one LPM-capable physical server to another compatible server. Well, what do we mean by that? That means that there's going to be some server requirements, there's going to be some firmware requirements, there's going to be some operating system level requirements, the HMC has to have certain levels, etc. There's a lot of planning that goes into this to make sure that you get it right. LPM servers typically are managed by the HMC. There are other options that you can use in terms of PowerVC, NovaLink, etc. All the examples I'm going to use in here were done with an HMC. You'll also see that there's some terminology. IBM refers to LPARs sometimes as LPARs, sometimes as virtual servers, and sometimes as virtual machines. I typically tend to use the terminology LPARs, but any one of those three can be interchanged. I have some documents here that you might find very useful. They specifically have to do with firmware support for LPM and migration modes. We're going to start with some definitions. So there's several different kinds of partition mobility. When people talk about LPM, what they're typically talking about is active partition mobility. And that is where you take an LPAR that is currently running and you migrate it from one machine to another without disrupting the operation of the operating system or anything that's running in that LPAR. There are, however, some other alternatives. One is inactive partition mobility, and that is when I actually shut an LPAR down and I migrate it. Now that is not the same thing as dead LPAR. If an LPAR has crashed, you can't use any of these options to move it. These are only used for healthy LPARs that have either been shut down or are currently active. You can also use suspended partition mobility. That's where I suspend a partition and then I migrate it and then I unsuspend it at the other end. All of the partition mobility options refer to the same feature, which is LPM. So what happens when you do an LPM? Well, the first thing that happens is you validate the configuration. It then creates the new LPAR on the new server and creates the new virtual resources. If it requires the same amount of memory and CPU, etc. as the LPAR currently has. So those resources have to be there. If they're not available, the LPM will fail. It then migrates the state of the LPAR and memory. So it's going to migrate the memory, the hardware page table, processor state, MB RAM, time of day, etc., etc. Once everything's migrated over there, it removes the old LPAR configuration and it frees up the old resources. Inactive's a little bit different. It does many of the same steps like validating the configuration, creating the new LPAR, defining the profile, etc. But it doesn't have to migrate all of the memory. So what it does is it uses the last used partition profile. What that means is that if an LPAR is shut down and has never been activated, you can't migrate it. At a minimum, you have to activate it from its partition profile into SMS mode so that you can actually migrate it. A general depiction of LPM kind of shows you what really happens. So if we look at it, we're going from left to right. So on the source server, the partition profile gets copied over to the targets. The storage is then configured on the target. The mover server partitions, and we'll get into what those are in a minute, get activated, and the partition migration starts. It moves nearly all of the memory pages. It then shuts down the threads and reactivates them on the target, and it moves those last few memory pages. And then it will clean up all the network and storage traffic. Storage resources then get deconfigured from the source, partition profiles removed, and we're all good to go, and we're on the new server. And if you're running nmon actively on an AIX LPAR when it's being migrated, you will actually see the point at which the serial number changes. It's actually pretty cool. I grabbed this from a presentation given by Ian Robinson because it actually talked about all the different steps. It's pretty much saying what I just said from the depiction, but I just thought it would be useful for you to have this diagrammatically. So what are the requirements for LPM? Well, the first thing is planning is critical. You can't just wake up one day and go, I think I'll LPM. You need to know your hardware levels, which ones you can LPM between. You need to have your HMC at a certain level, and I can tell you right now that these were the minimums that were listed. They won't work anymore. You basically will have to be at different levels, and so you need to confirm all of those by looking at the firmware matrix, etc. With the HMC, you now have the option of remote migration. That means I can have two systems managed by different HMCs, and I can do LPM between them. They still have to have a shared storage subsystem. I can't LPM and not have storage. When we do LPM, it does require that we have virtualized SAN storage for everything. So you can't have direct attachment to storage and do an LPM. The same with the network. The whole network needs to be virtualized. Now, this doesn't impact the VIOs. The VIOs will obviously have dedicated LPARs, etc., because you don't use LPM on a VIO. At the time of the move, you can't have anything dedicated. You can't have any virtual opticals that are assigned to everything. And this is very important with IBMI. Your IBMI LPAR has to be in restricted I/O mode. What that means is that you can't de-LPAR in or add any real I/O devices. So it's very common in the IBMI world for people to have a fiber adapter in their system that has tape drives on it, and they simply de-LPAR it around their IBMI LPARs. If you want to be able to use LPM with your IBMI LPARs, you can't do that. So what you have to do is actually change that tape drive over to NPIV and use NPIV to move the tape drive around. So just be aware of that little gotcha. Some of the other prereqs, the servers have to be compatible. What that means is I can move a Power 6 to a Power 8, but I can't move Power 6 to a Power 9. Power 9 doesn't support it. I have to have PowerVM Enterprise Edition on all the servers. So I can't use PowerVM Standard Edition and do the migration. Now the new Power 9s come by default license for PowerVM Enterprise Edition, and on a Power 8 you can get a temporary license so that you can use LPM to migrate when you're doing a move from Power 8 to Power 9, but just be aware you need Enterprise Edition. All of the LPARs have to be on the same open network, and you have to have RMC established. It must be working. So I can't migrate an LPAR when RMC is not working. It will fail. And of course the LPARs have to be under the control of VIO servers. You need to make sure your VIOS levels are right, you need to make sure your storage is virtualized, and you need to make sure that the storage that the clients are using has been zoned and mapped or masked to both the source and target, and that we use both the WWPNs. So each virtual fiber has two WWPNs. One of them is the default, one is for LPM. All of those have to be zoned and mapped to both the source and the target. If you don't do that, really bad things can happen. And I've seen situations, because of how it does the boot, it actually does that on the server processor, where I migrated it and somebody had not done the zoning and masking, and I completely trashed my boot LUN. So be very, very careful, make sure that is done. You cannot migrate LVM based disks. So if on your VIO server you're doing VSCSI and you're passing over logical volumes, you can't do it. You can't migrate local storage. Everything must be on the SAN. And your disks have to be, as I said, on the SAN, but they also have to have a reserve policy of no reserve. If you have a reserve policy of single path, the migration will fail. And as of 2.2.4 of the VIO server, there is a new pseudo device for checking on the H disks. And that pseudo device is called VIOS LPM0. And then of course you have to use a shared Ethernet adapter because everything needs to be virtualized. Now it has to be virtualized prior to the migration. So what some people have done is, for performance, they might have a dedicated fiber adapter and they DL-PAR it out before they do the LPM. So they may have a shared environment where they have both dedicated and through the VIO. That's pretty unusual now. Most things that people just virtualize. A couple of other things. The partition at the receiving server, there can't be any partition that has the same name as the LPAR being migrated. Right? If mine's called AIX1 and there's already an AIX1, I can't migrate. And as I mentioned earlier, you've got to have the resources at the other end. So some things you need to check is you go to the HMC on the server and check the LPAR under capabilities and make sure that you are actually LPM capable. You also need to make sure that that the box under the general tab on the VIO server at each end has the MSP box checked. The MSP is the mover service partition, and that is what is actually used to control the migrations. It will have what's called a VASI device defined. We're going to talk about those more in a little bit. The hypervisor is going to automatically manage the migration of CPU and memory, and you'll find that the operating system migration applications, etc., have to be migration aware. There's like a bunch of requisites. Probably the most important one is that the LMB or memory region size needs to be the same on both servers. You need to check on the HMC what that is set to. It'll show up as the memory region option, because this requires a whole server reboot to change. So if you have to change it so that they're all the same, you're going to have to power the server off and on. So one of the things that I do as part of the design is I double check before I do any kind of a migration that those are the same. And actually when I set up a server, I find out what the standard is that they use, and that's what I set that server to. Another point to note is that there can be some issues with Oracle and licensing when you have LPM available to an LPAR. As of HMC 884, there is a process to actually disable LPM, and actually you can go into ASMI and do it as well. So if your server's only been used for Oracle and you don't want to run into licensing issues and you don't plan to use LPM, then that's something you want to look into. So one of the things that you'll run into is you have to have processor capability. What is it? Compatibility. What does that mean? Well, I always set my compatibility mode to default. What that means is after I LPM the LPAR, it's going to be in the same compatibility mode it was in on the old system. So if I'm set to default but I'm running on a Power 7, I'm really running in Power 7 mode. When I migrate, I'll be running in Power 7 mode. If I then shut the LPAR down and reactivate it, it will come up in the mode that is the default for whatever server I'm on. You need to be aware of that, because if you want to migrate, if you want to LPM back from a Power 8 to a Power 7, you need to make sure it stays in Power 7 mode. And obviously with Power 7 mode, you don't get SMT8 and so on. You won't get the ability, if you migrate from Power 7 to Power 8, to use SMT8 on the Power 8 until you shut it down and bring it up in Power 8 compatibility mode. There's a lot of documents out there that show you all the different compatibility modes and what can be migrated to what and what you should set it to, but I just want to make sure that you're aware of this. So I always just set it to default. And you can tell what your compatibility mode is by looking at the properties for the LPAR and go down, and you'll see down here that it's set to processor compatibility mode is set to default, but it's effectively running in Power 8 mode right now. Now Power 9 has a couple of different compatibility modes. It can run in Power 7, Power 8 or Power 9 base, and I think there's another Power 9 mode now. So you should look at that and check, and one of the things you need to determine with your LPMs is, am I going to want to LPM to and from different architectures? Or, because if that's the case, then you need to set your compatibility mode to the lesser of the two. So if you're going to be forever migrating between Power 8 and Power 9, you need to set your compatibility mode to Power 8. If you're going to be migrating to Power 9 and never going back, then you can set it to default, and at some convenient time when you reboot, it will come up in Power 9 mode when you reactivate. This is a list of the generations that you can do LPM with. It was initially came out on Power 6. You can migrate from Power 6 to Power 7 or Power 8 and back. From Power 7 or you can go to Power 6, Power 8 or Power 9. From Power 8 you can go to Power 6, Power 7 or Power 9. From Power 9 you can only migrate with Power 7 and Power 8, and clearly Power 9. So just be aware of that, because if you've got Power 6s, you're going to have to migrate them to a Power 7 or a Power 8 before you go to the Power 9, or you can simply rezone everything, define the profiles on the Power 9 and just activate them that way, but you won't be using LPM to do it. So there are some requirements on the VIO servers. Your VIO server on both the source and destination have to provide some access to the same network, VLANs and subnets, with a shared Ethernet adapter. They have to have access to the same physical storage, either using external fiber channel like Virtual SCSI or NPIV, or external iSCSI storage using Virtual SCSI. You cannot have any virtual adapters marked as required or marked as for any client. They have to be specific to a client, and they have to be marked as desired. This applies to all of the virtual adapters from within the client profiles as well as within the VIO server. And your destination VIO server has to have enough virtual adapters. So if I have my VIO server set to 400 virtual adapters, it has to be set to at least that on the target. At least one VIO server per server has to be configured as an MSP. I tend to click the box on all of them, and then when I do the migration I pick which one I want to use, but you have to have at least one at the source and one at the target. And if you're doing any shared memory like AMS or anything, then you've got to have that set up at the destination as well. So what is this move of service partition? I mentioned that you have to set the box on the VIO servers, and it's done under properties. It's basically used to transfer the memory contents of the LPAR from the source to the target. So what happens is you define it as an MSP. That causes it to build something called a VASI, which is the virtual device created that's going to be used for doing the moves. And you can display it. It's called VASI 0. Any VIO server that has the MSP box checked can be used to control a migration. And it just uses the IP address of the VIO server when it does it. You can actually do dual MSPs, have two MSPs at each end to increase the bandwidth, and there's actually a button for MSP pairing during validation where you can choose the pairs. And you should be aware that the network speed for the MSPs, which is the connection between the servers, actually impacts the time for the transfer. So if you've got a single MSP and you've got 200 gig to transfer on a 10 gig network, it takes about 3 or 4 minutes. So you can do the math to figure out what that would be on a 1 gig network or whatever. I would highly recommend that if you're doing a big LPM to migrate somebody over because you're about to do maintenance or whatever, make absolutely certain that nobody in the network team or storage team is doing any work on the network or storage at the time, because it's pretty awkward when you're in the middle of an LPM and someone pulls your storage or network out from underneath you. You don't want to have that happen. So I mentioned the VASI, and you can check that by doing an LSDev. You can also do an LSATTR and see what its configuration settings are, and an LSconfig on it. I've never had to change any of these settings, and I certainly would not recommend you change them without talking to IBM. There's also a VASI stat command that you can run as padmin to get statistics on how the VASI is doing when it's doing transfers. So unfortunately the system I ran this on was not doing any LPMs and was not particularly busy, so you're not really seeing any valid data, but at least it gives you an idea of what you can see, and you can actually get p-hype statistics, which is very useful. So I mentioned that you need to check that box for the MSP on your VIO server. So you go on the HMC, you bring up VIO server properties, and you go down and you check, and you put a check mark in that move a service partition box, and then you just save it. And you find it under advanced, by the way. It's not, when you go into the properties, it doesn't show you the advanced. You have to check on advanced. And then Below that, you'll see the migration capabilities, and it will actually tell you what it can do. So what it's telling me is it can do up to 8 active migrations or 16 inactive migrations at a time. The MSPs have been around for a very long time, and there's actually a document out there on the IBM support pages about them, going back to version 2.2.5 actually of the VIO server. So this is just showing you the couple of different options where by default, if I'm doing an LPM and I don't choose the dual service pair, it's just going to have one MSP transferring to one VIO, and obviously it's going to be a little slower. If I do the dual MSP pair, you can see that I've actually got multiple transfers going on at the same time. For the same migration, that's obviously going to perform better. Now you select the pairings when you're doing your migration. One of the options after you fill all these fields in is you click on MSP pairing, and it gives you the option of picking which VIO server at each end that you're going to map them with. And if you've actually got dual MSPs set up, it will actually let you pick like 4, 2 source and 2 target. You also, I find I typically have to go through and pick which slots map to which VIOs. It doesn't seem to get that, so I normally do that. I also will click on View VLAN Settings and make sure that the VLANs are all there, because that's something that you can run into, is that the VLANs are not defined at the target server. That's going to get you a problem. And then you normally would click on Validate. It will run a full validation. If that works, it'll let you click on Migrate. If it doesn't work, you won't be able to click on Migrate. Now this is actually an example where I was using a remote server. So you can see I have a remote user. I had actually set up the SSH keys, etc., so that I could actually talk to the remote HMC and use the LPM account as the account that does all the migrations. So what are the mobile partition requirements? You need to check for operating system support. You need to check that you have a functioning RMC. You need to make sure that there's no workload groups. Nobody can be logged into the console at the time, because the console is a local device. Now that will only get you a warning and they'll get kicked off, but it's just, what I normally do is if I see that I get that warning when I do the validate, I go and make sure that whoever's logged on the console is logged off, because I just don't want to run the risk of any unnecessary problems. You need to check that your storage is zoned and mapped or masked, both at the storage and the switch, and that it's set to no reserve in the LPAR. And that's something you would set in AIX and you would set in Linux. I'm not sure that you have to do anything in IBMI. Make sure there's no adapters set to required in the profiles. If they are, you're going to have to change them, shut the LPAR down and bring it back up by reactivating the profile, not just a reboot. Again, you've got to make sure the LPAR name is going to be unique on the destination server and the MAC address. You need to make sure it's not the service partition. Now, one of the first things I do when I bring up a new server is I get rid of the service partition anyway, because I can assign that at any point if I need to do it, to use it. But I want to make sure that if I decide to use LPM, I'm not going to run into a problem. And most of us are now on servers that don't have IVEs, etc. So the next couple of ones are irrelevant. We talked about compatibility mode, and obviously we have to make sure that the network is compatible with the destination VIO server, and that's the VLANs and stuff that I was talking about. There are some things that you can do with an inactive migration that you cannot do with an active migration. So if you're using huge memory pages, BSR arrays, if you have redundant error reporting turned on, or you have physical I/O, you cannot do an active migration. However, you can do an inactive migration, so you can shut the LPAR down, migrate it, and bring it back up, but you may run into problems if the server at the other end is not capable of doing that, or as an example, can't provide the physical I/O. If you are using something like active memory expansion, then you need to make sure that the destination server is enabled for active memory expansion. So if you didn't buy it on the target server, then you need to turn it off on the LPAR, shut the LPAR down and bring it back up without AME, and then migrate it. And then you've got the same thing with suspend resume. And as I said several times, the target server has to have enough CPU and memory resources for the LPAR to be moved. It's not enough to just change the entry in the profile. You actually would need to reactivate it with the reduced profile if the server at the other end has a reduced set of resources. So what you could do is change the profile, sometimes DL-paring these resources out, then migrate it, and then DL-par them back in, depending on what's going on. But just be aware that you have to have enough resources. Now, if you're migrating from a server that is capable of doing 0.05 or 1/20th of a core, but you're trying to migrate to a server which is like a Power 6 or Power 7 that can only do 1/10 of a core, then you need to make sure that the destination server shares the same capabilities. So if you're going from Power 7 Plus to anything Power 7 Plus and above, you won't have a problem. But if you were trying to go to a Power 7 or a Power 6, you could run into this. So just make sure that there is compatibility there between how your processor units are defined. I already talked about the LUNs and NPIV and zoning and mapping. I can't stress that enough because that's where I see 90% of the issues with LPM, of failed LPMs, is because things are not zoned and mapped. I did publish back in 2018 a guide to live partition mobility. Even though it's now 2020, a lot of the recommendations in that have not changed. With respect to migrating IBMI LPARs, I mentioned this earlier, but you need to make sure that the destination server actually supports IBMI, has to be enabled for it, and you need to make sure that it supports restricted I/O mode. We also have to put the IBMI mobile partition into restricted I/O mode. That's going to require an LPAR reboot, and it is going to disable the ability to use DLPAR of any physical I/O, which means if you use tape drives and you DLPAR them in and out, you will not be able to do that. You will have to use NPIV for them. So just be aware of that, because switching over from that DLPAR to using NPIV is going to require some retraining for your operators or whoever takes care of tape drives. And of course, no tape drives can be active at the time. I talked about this in the storage section of part 2, but I want to touch on this again for people that haven't watched that. So you've heard me talk about zoning and mapping or masking. So zoning is when a switch on the SAN is configured to allow the switch port to talk to the storage and to the worldwide port number for the LPAR or server. So that's specifically allowing the VIO or my client LPAR to talk to the switch, or in the case of the storage subsystem, for it to talk to the switch on that port. Mapping or masking is done at the storage subsystem. Sometimes it's called LUN masking. That's when I build all my LUNs in the storage subsystem, and I then provide to those LUNs a list of the worldwide port numbers allowed to access those LUNs. So that's where I would put all of the worldwide port numbers for my client LPAR, so that it knows that LPAR AIX1 is entitled to actually look at and work on these LUNs. So zoning is the switch and mapping and masking is the storage subsystem. You have to do both. And in both cases, you have to, for NPIV, zone and map the WWPNs for the virtual adapters. And remember that each virtual adapter is going to have 2 WWPNs, one that's the default and one that will be used by LPM, and you must zone and map both of those. If you're using VSCSI, then we only deal with the what I call WWNs, which are the actual real adapter ones. Those all start with a 10 or a 20, and those are actually the VIO server. And then the WWPNs will always start with a C0. You can run an HMC scanner report, you can log into the LPAR or VIO or the HMC to find out what those are. Another requirement for NPIV is that you must have an NPIV capable switch port. You can run the LSN ports command as padmin and find out whether or not you actually are connected to a switch that is NPIV enabled. If you are direct connected, you can't use NPIV. You're going to have to use VSCSI, so just be aware of that. It's really important not to confuse zoning with mapping. Zoning is the switch, mapping is the storage subsystem, and you have to do both. I mentioned already that every virtual fiber adapter for an LPAR has 2 worldwide port numbers. And when you're doing LPM, it actually flip-flops between them. If you do not map these properly and zone them properly, and you do an LPM, you'll damage your boot image. And I have actually done that, and it's not a pleasant thing to recover from. So it's really important that you double check that all the zoning and all the mapping is done correctly before you start working with LPM. So with VSCSI, again, we use because the VIO server is going to own all of the storage, we use the WWPNs of the actual adapters in the VIO. So those are the ones that start with a 10, and you can look at them on the VIO with the lsconfig VPL fiber adapter. All of the MPIO drivers get installed in the VIO server, but any mirroring is done on the client LPAR. And you look at the VSCSI mappings using the lsmap -all. Any tunables for the fiber adapters are also set in the VIO. NPIV is different because we're going to use the worldwide port numbers that are created when we create the client LPAR. When you create the virtual adapters, which are the virtual fiber client adapters in the client profile, at that time it actually creates the virtual worldwide port numbers. And like I said, it creates them in pairs for each adapter number. Since the VIO server doesn't see the disks, any MPIO drivers will have to be installed in the client LPAR. That's the same with any device drivers as well. And you monitor them by basically looking at lsmap -all -MPIV. You will actually see fiber adapter definitions in the client LPAR as well as the VIO, and tunables have to be set in both. But be aware the client LPAR settings have to be less than or equal to whatever is set in the VIO servers. You need to set the VIO servers, shut them down, reactivate them, and then you can make the changes to the client LPARs. And then one last comment is there are some storage subsystems, and the VSUP 5000 was one of them, where you may also have to zone the real WWNs for the adapters, even though you're using MPIV. Now you don't map them because you don't want to see the storage at the VIO, but you may have to zone them at the switch. So how do we find these WWPNs for NPIV? Well, the easiest way is to go to your HMC, go to the LPAR profile and click on virtual adapters, and then go to any one of your virtual fiber channel adapters. So here I clicked on 70. Then you click on advanced, which I cut off, I'm sorry, and you'll pick login, logout fiber. So down here on the bottom here you see the login, logout fiber, and it now gives me a list of all my slots and all of the virtual fiber WWPNs. So you can see that slot 180 has 2 that end 48 and 49. The first one is the default and the second one's the LPM one. Number 70 has 28 and 29, and if I go to the actual adapter I can see the same thing just for that adapter, and that adapter is coming from VIO1. So I always have a plan where different adapters have different sets of numbers. So on this server 180 and above is tape, which I'm only assigning from VIO2. 70 through 89 is going to be VIO1, 90 through 109 is going to be VIO2 for client fiber, and then I have different rules for client SCSI. It varies by implementation, but the most important thing is that you have something that is standard and that you document it, because you're going to find that documentation, when you start to get into, well actually when you get into VIO servers, never mind LPM, is going to be critical. When I do zoning, I like to do zoning very simply. Actually, I prefer to have somebody else do the zoning, but a lot of the time you'll see people zone by fiber adapter and port number. Well, the issue is that with the VIO servers, and when I'm doing NPIV, I can change all of that. I can use my VFC map command, and one day, this number here could be going to FCS 0, but something could happen, so tomorrow I move it to FCS 1. So when I do my zoning, what I do is I set up on switch 1, I'll have a zone by the server name, so NPIV AIX1, and in it I will drop all 4 of the worldwide port numbers that I have assigned to that, and then on switch 2 I'll drop the same 4 into that zone. The only thing that's different in the zones is these 3 here in bold and these 4 down here. The ones that start with 50 are the storage subsystem, and the ones that have a 10 and a 20, those are actually tape drives. So those are going to be different between the two zones, but everything else I keep the same. It's very simple, it's easy to understand, it's easy to document, and it's easy to fix when you have a problem. When you start to have zones that are pages and pages long because somebody is zoning every adapter port, A, it's not relevant in an LPM environment, and B, it is a nightmare to debug. So the next step is, obviously I've done my zoning and mapping, but actually my client LPAR and my VIO server have no connection built between them at this point for the storage. So for NPIV, what I'm going to do is, firstly I have to find out the VFC host number. For every virtual adapter that I define, they get assigned at the VIO a virtual host number. I go through, I figure out which VFC host is which adapter. So in this case I can see that when I do an LS map, I can see that 108, adapter 108 here, is actually VFC host 20, and it's LPAR ID number 17, which is AIX test 1. Now you're typically going to see 2 or 4 of these on a VIO for each LPAR, depending on how many fiber adapter ports that you have cabled. So if I have 4 adapter ports, FCS 0 through 3, I will create a VFC host or a virtual adapter for each port for my client. Or I may only use 2 of them, but I need to know which ones those are. So I can use the VFC map command to say, I want you to assign VFC host 20 to FCS 0. And then VFC host 21 might be a different adapter number on the same LPAR. I'll assign that to FCS 1, etc. What you don't want to do, which I have seen done, and it breaks LPM really badly, is somebody took the same VFC host number and assigned it to FCS 0, FCS 1, FCS 2, FCS 3. I can't even believe it worked, but I can tell you that it really broke LPM. Once I've done the VFC map and I do an LS map, if the LPAR, if I then boot the LPAR, you'll actually see that that LPAR is out now logged in on FCS 0. I had mentioned earlier that RMC is really critical. You need to have a functioning RMC, which is the connection between the HMC and the LPARs, in order to be able to do dynamic LPAR or anything else. If you find that you don't have a functioning RMC, then you need to fix your RMC issues. On the Power, I've been working with the IBM Power Cloud lately, and RMC has to work there for DLPAR to work anyway, or for you to be able to add or remove resources. So these are the steps that they gave me, which do work in order to fix RMC on the Power Cloud. One thing to note is you do have to have a network adapter that's defined as IP version 6, because that's what they use on the Power Cloud to do any kind of maintenance. So what I typically will do is make a list of all my adapters, and if there isn't one that's INET 6, then I find, let's say EN 0, 1 and 2 are in use, then I will do the autoconf 6 against EN 3 because it doesn't exist yet. And then you can go through with all the unconfiguration, etc. On a regular AIX LPAR and a regular server, I've given you the link to the fixing no RMC connection error. But you need to check your RSCT levels, check the status of your daemons, and then you can run diag RMC on the HMC, and then on the LPAR you're basically stopping and starting RMC. If that doesn't work, there's a whole bunch of additional steps that you can go through, and the document that I've got linked to here will take you through what all those steps are. So I mentioned inactive migration earlier, and as I said, there are some differences in configurations for what you can do with inactive migration than what you can do with active. An LPAR to be used with inactive migration is one that you shut down, not one that just crashed. If you have huge memory pages or barrier synchronization registers, if you have any physical I/O, any of those kind of things, then you're going to have to shut the LPAR down and use an inactive migration. And as I said earlier, when you're doing inactive migration, the LPAR has to have been activated at some point. And you can basically just bring it up in SMS mode and then shut it down. What's interesting about inactive migration is, unlike an active migration, it leaves no log entries on the HMC, so there's actually no record that it ever happened. Active migration does make log entries that a migration was done. Remote migration is something that I have found to be particularly useful, and in fact is a great way to migrate to a new server. So let's say I'm doing a Power 8 to a Power 9 migration. I can install my new VIOS servers onto Power 9, I can get everything configured the way I want it, and I can even make this work with enterprise pools, although that's a whole nother presentation. But then I can just LPM everything over, as long as all the zoning and everything is done correctly and the mapping. The first thing you have to have a local HMC managing your source and a remote HMC managing the target. They don't have to be at the same level, but they do have to be at compatible levels. You have to have functional RMC daemons, and obviously we have to have network access to the remote HMC. So the first thing you have to do is set up an account. I used LPM account, and set up SSH key authentication to the remote HMC and to all of the involved LPARs. Otherwise, it's just all the normal requirements that you would have when you're doing a single HMC migration. If you're using an FSM to HMC or vice versa, then you need at least version 7 of the HMC. You actually really should be on version 9 of the HMC now, because again, that's one of those things where support is being dropped. So how do we do these SSH keys? I've got a link here to how you would do it, but basically I create a user ID for LPM. I go to the source HMC and I create the keys there, and I have to make sure I do things like copy the keys, test the communication channel, etc. Either one can be the source HMC once you get the keys run. So those SSH keys are very important. Something else that's come about more recently with Power 8 is simplified remote restart. I've not had a call to use this yet, but I wanted to give a mention to it so that you can actually look into it yourselves. It was introduced on Power 8 and it's really designed for unplanned outages. So you have to enable your LPARs for SRR ahead of time, but what it will actually let you do is if your whole server crashes, which is pretty unusual, you're not able to use LPM because the server's down, so you have no source. But if you have it set up for SRR, you can actually move and restart the LPAR literally within minutes of the LPAR going down. Of the server going down. So I've got an article here by Nigel and also a link to the IBM Tech doc that talks about this. So how do you set it? In your LPAR properties, there's a simplified remote restart box, and there's also an allow migration with inactive source storage BIOS box. Both of those need to be checked. They're free, they cost you nothing, so it makes sense to me for you to use them. Earlier I had mentioned that at 224 there's a new pseudo device called VIOS LPM 0 that you can set to basically make it check that all the zoning is done. And what we can turn is source validation and destination validation on. If you turn these on, it's going to go and check for every disk and that it is zoned and mapped all the way through. If you've got a lot of disks, it's going to take a long time. But you will get errors that are a little bit confusing, but you can figure it out. So depending on what I'm doing and how confident I am, I usually leave this turned off and I turn it on when I need it. But just be aware that you do have that option, and it's the VIOS LPM 0. So the source LUN attribute is basically used to enable and disable LUN level validation. And the dest LUN is actually used to disable LUN level validation of NPIV for different operations. So I can turn it on, I can turn it off, and I can do end-to-end validations. I can have it set just for remote restart but disabled for LPM. There's a number of different settings that you can use to do the validations. If you do turn them on and you do a validation and it can't find one of the WWPNs, you'll see errors like this, where this is saying, I was trying to find on VIO1 these WWPNs and I couldn't find them. So the one that is missing is actually the C050. This was not zoned or mapped to VIO1 from the source adapter. So now I have to go and find out, what's going on with the zoning and masking, etc. So it's very useful, and it's something that you should look into as a something you could potentially use if you do have an issue with being able to check the storage. I usually have access to the storage subsystem myself, so I can check the switch and I can check it, or I request a show output from each of the switches before I start, because if I'm doing a massive LPM, I really don't want to run the risk that I'm going to break the system. And if I'm really not confident, then I insist the LPARs be shut down and move them shut down. That way, if there's no storage mapped at the other end, the LPAR just won't boot, versus it migrating across and having nothing to stay talking to. And it's a very weird thing when it's not zoned and masked properly. The LPAR, if you don't have those settings set, will migrate, but the minute you type in a command that's not cached, that's when bad things happen. So you don't want to find out the hard way. So what could go wrong with LPM? Well, there's a lot of things that can go wrong. We've got to make sure you meet the prerequisites. But if you're using LPM, there are specific things you need to do to open a PMR, or cases they're now called with IBM. So you're going to go to My Cases, and there's actually information provided at 2 different links on all the stuff you have to gather for a test case. So you may as well gather all that ahead of time and save yourself going back and forth with IBM as they ask you to do all these things, because they will literally send you a list of questions about your VIO servers and your environment for you to fill in. A lot of the problems you'll see are missing prerequisites, HMC, VIO server and firmware levels. So before you open a PMR or case, you want to check all of those. Also, I mentioned processor compatibility before. You're going to get, if you have never booted an LPAR and you're trying to LPM it, you may get a really weird message about processor compatibility that is very confusing. What you want to do is go to the HMC and look at the graphic of the list of LPARs, and if you see 0.0 for PUs, that means this LPAR's never been booted, and so it won't validate. Because remember, you can't LPM, even inactive, an LPAR that has never been booted, because it tries to use the profile. So if you get that weird message about processor compatibility, most likely because the LPAR has never been booted. I've mentioned the VFCs being mapped to the same FCS. Please don't do it. And then here I've given you a list of commands that you can use for validating LPM in your remote HMC, checking migration states, etc., etc. Again, I want to thank you for listening to this session. I hope you found it useful, and please don't hesitate to send any questions. And additionally, please do fill an evaluation. Thank you, stay safe, and I hope you enjoy the rest of the conference.